I'd now like to introduce on Aftikar to talk to how we can transform healthcare through data and insights. So please make him welcome.
Welcome, and thank you for joining us today. We'd like to start off by acknowledging the traditional custodians of the land we're meeting on, the Ngunnawal people. We acknowledge and pay our respects to their continuing culture and the contribution they make to this city and this region. We also like to acknowledge and welcome other Aboriginal and Torres Strait Islander people who are present today. You are a public sector healthcare business owner or a technologist who's interested in data analytics. You want to do amazing things with your data, but you're unable to work at the velocity and scale that you need while ensuring the right security and governance to meet your requirements. We're here to tell you that there is a better way, but don't just take my word from it. You'll hear from a customer who's using the power that AWS provides them to solve similar challenges to what you're facing today. My name is Owen Iftikhar, and I'm a solutions architect with AWS. I'll be joined on stage by Harmeet Chabra, Director for Data Warehousing and Business Intelligence at eHealth New South Wales. Extracting and leveraging insights from data is imperative to every organization and industry, but even more so in healthcare, as data-driven decisions help support the delivery of efficient, timely, and safe healthcare for patients and the community. Today, we'll go through some ideas of what a modern data architecture looks like and how you can use a modern data architecture as a foundation to deliver on your data strategy. Harmeet will then dive into how New South Wales Health are leveraging AWS and partner services to build such a foundation to deliver on their mission. More and more organizations are recognizing that data really is an asset. A 2022 survey by New Vantage Partners found that almost all businesses want to be data-driven and are investing as such. And this should come as no surprise. But what's surprising, in fact, is the fact that only about a quarter of those have been successful. A lot of our customers tell us that they struggle to even define what data-driven actually means, and aligning that definition between business and technology stakeholders. Historically, it's taken a long time, effort, and cost to build components and infrastructure to support your data strategy. But that's changed with cloud and the ability to pay for what you use and the ability to scale rapidly. What that's done is really created this amazing flywheel for data innovation, where you can build products fast and get them to your customers really fast, right? And you can tie these to specific business outcomes, so you can determine and ascertain value quickly. What this in turn allows you to do is get these products out to your customers, get their feedback quickly, so you can continue to innovate, iterate, and improve your products. And this is greatly accelerated by cost-efficient and scalable innovation and experimentation. Let's start off by having a quick look at the diverse sources of data in healthcare, where data is being generated every second. On the left, you have your traditional healthcare systems, your core clinical, operational, and financial data sources. But as you move to the right, you start to see some of the more specialized, more interesting data sources. Things like medical device data or patient engagement data from telehealth or patient-facing applications or citizen-facing applications for that matter. And then you have very specific data sets like medical imaging or IoT. This in turn opens up more and more use cases for driving value from this data, allowing customers to rethink how they provide better patient-centered care and support research. But managing and driving value from this vast amount and type of data isn't without its challenges. Efficient, scalable data management solutions are costly and can take a long time to stand up. Customers struggle with being able to get real-time insights or timely insights from their data. And of course, ensuring sound security and governance for your most sensitive data is absolutely paramount. Traditionally, in data analytics, we've used the concept of a data warehouse. In a data warehouse, you extract data from your source system, transform it into predefined relational schemas, and then run your business intelligence and reporting on top of it. The warehouse approach uses structured relational databases, which means that we've often struggled to bring in semi-structured or unstructured data, and we've had to use separate systems for that. And that's led to the existence of data warehouse silos, where your data is distributed between multiple systems. But this isn't to say that these platforms haven't had their place, and they've delivered value for a long time. However, we're consistently reaching the limits of this approach, and we've been forced to evolve. The next evolution from the data warehouse is the data lake, where your data is stored in one place and curated in place. In the case of a data lake, the data lake stores structured, semi-structured, and unstructured data in a central place, and decouples storage, which is cheap, from compute, which is usually expensive. With the data lake, you land your data in its raw format, transforming the data after it's been landed. That reduces the effort and complexity with loading the data in the first place. You can then apply a wide range of analytic engines executing against your data in the data lake in parallel, which helps you scale tremendously. However, a data lake doesn't solve all your problems. Services purpose-built for a specific use case will often outperform more generalized services like data lakes. Also, it's absolutely imperative and important to get data in the hands of the people who need it in a system and an interface that makes sense to them, where they can actually use that data. And that's where the modern data architecture comes in. With a modern data architecture, we include purpose-built data services around the data lake in a holistic view of the ecosystem. You start with that scalable data lake at the center, but then you cover it with purpose-built services around the perimeter. But to be able to take advantage of this approach, you need to be able to seamlessly move your data between these services. You need to be able to move your data in the amount you need to where you need it for however long you need it for. An example of this might be an approach where you store your historical data in the data lake, but move a year's worth of data into a data warehouse for your everyday reporting and business intelligence requirements. Or the other way around, where you might be creating aggregate views and abstractions of your data in the data warehouse that you push back into the data lake for long-term retention and continued analysis. And this is all supported by a unified governance model to make sure that the right level of access is granted to the data with the right audit controls. Now let's bring these concepts back together to showcase what an effective modern health data platform can look like. On the left, we have those diverse set of data sources with the modern data architecture at the center. That's your scalable data lake and your purpose-built data stores. We start by ingesting data from all our internal, customer-facing, and external sources. Now, at this point, you want to be able to have the right service and interface to ingest this data at the frequency and the volume that you require, from real-time device data to batch uploads to support your requirements. The data, once it's stored securely, can be transformed or presented directly to your users for analytics or data science requirements. And this really is that democratization of data that allows for rapid experimentation and analysis for your users. This, in turn, helps you power use cases that deliver value to your business, from real-time insights to large-scale processing or machine learning outcomes, or sharing of data for research and collaboration. This is all underpinned by a security and governance model, ensuring that you're able to meet the compliance and regulatory requirements for your organization. You can catalog your data, you can discover it, you can audit your controls, ensuring data security and quality. And one thing I want to highlight here is this architecture, or the concept that we're presenting here, is completely modular, which means that you can start small with a specific business outcome in mind, but add functionality and scale as you go. And as with all things AWS, it's completely pay for what you use, or pay as you go. So you only pay for the amount of data you store or the data you process. Let's now look at how this translates to the real world, some of the concepts we're talking about. I'll welcome on stage Harmeet from eHealth New South Wales to talk to you about their work in building a statewide data lake and analytics platform on AWS. Their mission to support a patient-centered, efficient health experience, and how they're leveraging some of the patterns we talked about and the scalability that AWS provides them to try to deliver on that mission. Over to you, Harmeet.
Very well, man.
Good.
Good. Thanks, On, and good afternoon, all. Imagine you have built an algorithm for early detection of sepsis in an emergency department setting. You've trialed this in a couple of hospitals with promising results, and now you want to roll this out to the entire state. Or imagine you have built an algorithm that can reduce the patient readmission risk by up to 50%, and you want to roll this out to the entire state. Or you may be working on your next premier's priority that requires you to build a statewide data collection. No matter what the initiative is, you have to start with the raw data from these frontline clinical and corporate systems. And if you're working at New South Wales Health, you will very quickly come to a realization that it'll take you around 1 to 2 years just to be able to build that statewide data collection. Now, this can be quite frustrating, especially if you're working on a time-sensitive project. Let's take a deeper look into why we have these challenges today, what are the big impediments, and how we are trying to solve them. So New South Wales Health is comprised of 30+ health organizations. Out of that, 15 of them are local health districts responsible for managing hospitals on the ground. We have some agency pillars, we have specialty networks, and we have some shared services organizations like HealthShare and eHealth. Now, because of the way we historically organized ourselves into area health services, the clinical system landscape is highly fragmented. What I mean by that is we have approximately 9 electronic medical record systems running on different vendors' technologies. We have 9 patient administration systems running on different vendors' technologies. And similarly, we have lots of other peripheral clinical systems like maternity systems, oncology systems, again running on different vendors' technologies. In addition to that, these vendors sometimes impose restrictions in terms of how you can extract data from these systems. You probably have to use a proprietary command language sometimes or a proprietary tool in order to be able to extract the data from these systems. To make the problem worse, these different instances of electronic medical record systems or PAS systems could also be configured quite differently. I'll give you an example. Let's say if you're trying to figure out the diastolic and systolic blood pressure reading for a cohort of patients from entire state. And this information could be hiding in table A in the first electronic medical record system. In the second instance, this could be hiding in a different place in the same table, or this could be in a different table altogether. So in order to really be able to build a statewide data collection, you have to work with the application owners of each of these instances to understand the nuances of how these systems are configured today. You also have to prove to these application owners that the extract that you've written is not going to degrade the performance of these live production systems. Now, this is quite important because at the end of the day, these systems are being used to manage patients on the ground. If you aggregate all these problems together, it's quite easy to see why it takes such a long time to actually assemble a statewide data collection. I've heard some anecdotal evidence that people have spent up to 3 years sometimes building a statewide data collection. Now, in that time frame, sometimes the priorities shift. That project is no longer relevant, or the funding pool might have dried out. So this is a big problem. Let's have a look at how we're trying to solve this. We have built this enterprise data lake, which is a singular source of data from our frontline clinical and corporate systems. And the data is available, it's close to real time. And the best part is it allows you to mash up data, for example, from a maternity system with electronic medical record system or a rostering system, all in one place. It's quite important to note that data lake is not a replacement for a data warehouse. It actually complements the data warehouse and acts as a feeder system in most cases. Now let's have a look at how the landscape of assembling the data changes with data lake in the mix. You no longer have to work with these 9 application owners to understand the differences between how these are configured. You don't need to worry about impacting the performance of these live production systems. You can actually just go to a single source of statewide data and actually build your statewide data collection from there. You no longer have to work with these proprietary technologies because we are using open technologies like SQL or structured query language so people can draw data quite easily from this data lake. The data quality is also significantly improved. We actually provide users a full lineage back to the source system on how the extract was written. This is currently not the case in the traditional ways of drawing data from these frontline systems. A singular data ops team can also enforce the data governance policies of different local health districts quite easily on this platform. The time to value, which is the key here, it actually reduces from 1 to 2 years to a matter of a couple of months. Now, this is a massive shift, massive orders of magnitude shift in the way we operate today. Data lake is expected to drive a number of benefits for our system. The first and foremost is the efficiency. We are extracting the data once, and we are reusing it multiple times. So if there are 10 projects trying to write these different extracts with minor differences between them, they no longer have to go and write the same extract again and again and again on these frontline production systems. We are actually publishing the data dictionaries on the extracts which are already available on the data lake, so people can actually reuse what's already there and start from there and start enhancing those extracts. The data lake is close to real time, as I mentioned earlier. From the time somebody keys in data into these frontline systems to the time it's available on the data lake, it's less than 30 seconds. In most cases, it's around 10 to 15 seconds, which opens up the data lake for a much wider range of use cases. Things like clinical decision support use cases that need around 5 to 10 second latency. That's actually possible to implement on this data lake. This platform is also a fantastic enabler for machine learning and AI-driven use cases, because in most cases, we have full historical data available from these clinical systems, which is around 10 to 20 years worth of history. Data lake is highly secure. We have gone through our 5 internal stage gates of privacy and security assurance framework process. We have also digitized the data governance process, and which I'll talk about shortly. And data lake is also easily auditable. At any given point in time, we can provide our users full visibility into who has access to which data set, for how long they will have that access, and what's the purpose of that access. Data lake can be used to drive clinical insights, business administration-related KPIs, and it can be used for operational reporting quite easily. It's also a great enabler for research and innovative use cases. Let's have a look at the data lake architecture. There are 4 broad categories of source systems within New South Wales Health. We have New South Wales Health managed clinical systems. We have New South Wales Health managed corporate systems. Some external systems, this could be a federal or a state-based or a private organization hosted system. And we have software as a service products. The method of integration to the data lake varies depending on which type of source system we are talking about. 80% of our data is in these New South Wales Health managed clinical or corporate systems. And we use this very lightweight change data capture technology, which is proven to have no impact on the performance of these live production systems, to be able to replicate data in near real time into an integration database. From there, we provide our users a subscription facility so that they can subscribe only into the slice of data that's relevant for their project. Now, this is quite important because we want to keep our data lake clean for our users. We don't want to turn this into a data swamp, and they should only be dealing with the data that's actually relevant for their project. For external systems, we use a secure file-based ingestion framework that we have developed in-house. And for SaaS products, we have to use API-based ingestion because that's the restriction that's imposed by the vendors in most cases. Once the data is available in the integration database on demand, we can execute the pipelines to make this data available to our users, whether it's a structured data or unstructured data. All the structured data goes into a specialist data store, and all the unstructured data, which is things like discharge summaries or clinician notes, it stays in the Amazon S3. Now, that was the batch pipeline, which is actually applicable for use cases where you need to refresh data probably on a daily, on a weekly, maybe on an hourly or half an hourly basis at max. For more real-time use cases, we use a streaming technology to stream the data directly into the structured data store, which enables those clinical decision support tool type of use cases that I was talking about earlier. Now, for the consumers of the data, we provide them absolutely full flexibility on where they want to execute their analytics and BI workload. For example, if you want to execute your analytics or BI workload in a public cloud environment, you can absolutely do that with this data lake. If you want to run your analytics workload on premises, that's absolutely feasible today. And we have also built a secure analytics platform in-house that can also be used to directly connect with this data lake. For people who are more technology inclined in the room, here are some of the core services that we are using to build this solution. On the left-hand side, we have the source, which is your, typically a relational database that's underpinning a clinical or a corporate system. We use the change data capture technology to do a near real-time replication onto the Amazon RDS. And we have multiple instances of RDS running. At this stage, the data is still fragmented, depending on which system we have ingested. From here, on demand, we can bring data into the S3. And from there, we process data in such a way that we split all the structured data into one S3 bucket, and we send all the unstructured data into a different S3 bucket. From here, we take all the structured data, and we send it into Snowflake, which is a specialist data warehousing product that we use. And for more real-time use cases, we use Amazon Kinesis as a streaming technology to stream the data either directly into Snowflake, or we allow our users to directly tap into the Amazon Kinesis topics. Let's have a look at how the data governance today works for this data lake. The data governance considerations are extremely important at New South Wales Health. It's quite important to note that data lake is not a new data collection. It's a piece of technology that's there to facilitate access to the raw data. The local health districts always remain in control of their own data. To ensure we are not making any assumptions with regards to the existing data governance process, we have actually written to all the chief exec officers of these local health districts to nominate peak data custodians who actually sit on these data lake reference group. And they actually advise the data lake program on how to navigate the complexity of data governance within their local health district. We have also requested the CEs to nominate data access controllers who have this delegation or the delegated authority to approve access to the data from specific clinical systems. Now, this could be one person who is approving access to multiple clinical systems for a local health district, or these could be different people. So the way this digital workflow works today is when a trusted user in New South Wales Health wants access to data for any analytics or BI use case, they fill a digital form, and they submit this form. They actually have to select the different local health districts they want to draw data from, and the different clinical systems they want to draw the data from. And depending on how many local health districts and the systems they have selected, this request would go to either one or multiple data access controllers. From there, the data access controllers can take one of three actions. They can either reject the request because they're not happy with the available information there. They can request for more information, or they could approve the request. When they approve the request, it goes to the data lake product team that actually provisions a secure workspace containing only the approved data for the requester. From this point onwards, the requester has full flexibility on how they want to process the data further. They could process it directly in the data lake itself, or they could take the data downstream into another application or into a downstream data warehouse. So data lake is designed to solve the problem of access to raw data from these frontline systems and also the ability to mash these data sets together in one place in near real time. The data analytics platform is a separate product that we have built in-house. It's a secure analytics platform for New South Wales Health's existing analytics teams to cost-effectively leverage the cutting-edge analytics tools and infrastructure available in the public cloud ecosystem. This particular platform sits over our enterprise data lake, and both the enterprise data lake and the data analytics platform are built on our self-managed cloud foundation, which is your public health account with lots of guardrails built around it. While building this data analytics platform, we have considered multiple design principles. So security is absolutely at the forefront of everything we have done in this platform. So the kind of restrictions we have here is there is no data exfiltration allowed from this platform. It's like a black hole. Once the data ends up in the data analytics platform, it just never goes out. You have to do all the data processing inside the data analytics platform boundaries. And all of this runs inside the New South Wales Health Network. There is no internet connectivity in this platform, with the only exception where if you have a machine learning programmer or a data scientist who is trying to download some packages for building a Python or an R program from a trusted repository, that is actually allowed on this platform. Also, there is no access to any on-premises data sources. The entire data analytics platform is built using infrastructure as a code, which means the entire pipeline is fully automated. From the time a user makes a request for a data analytics platform to the time we actually deploy this as a package, the whole pipeline is fully automated. And we are also taking this platform through a privacy and security assurance framework, which is our internal process. What this means is that if you have an analytics team within a local health district, and they want to use these cutting-edge tools available on the public cloud ecosystem, and if they don't have the right level of maturity or the expertise within their organization to actually build this platform completely from scratch and wait for maybe 6, 7, 8 months to take it through the privacy and security assurance process, they can simply leverage what's already available on the platform. This whole platform is highly scalable. It can easily scale to petabyte-size information, and people only pay for what they use. Not only that, they also only pay for the duration they are using it. And this is possible because we are using serverless technologies where possible. We also publish a catalog of different analytics services that are available on this platform. So if there are 10 services available, a consumer can choose to only provision maybe 2 services out of the 10, and that's just a single click of a button. Let's take a look at some of the clinical use cases that are currently in the works on Data Lake. There are a number of quality and safety measures that can be observed and compared against the benchmarks to improve the maternity safety outcomes. That's exactly what Clinical Excellence Commission is trying to do with this Maternity Safety Intelligence Register initiative. The Outpatient Viewer application is a program delivery e-health-led initiative where they're trying to replace the paper-based outpatient appointment system. So if you are a patient who has a clinician appointment coming up in a hospital, typically you receive the reminder as a paper-based mail in your letterbox, and they're trying to basically make the entire process digital. So you can log into a portal and see all of your upcoming outpatient appointments. The electronic medical record to OMOP Odyssey data model, which is a open source data model, which is quite popular in the research community today. That's a mapping that Sydney LSD have already done in partnership with UNSW. What we are trying to do is lift and shift the work they have done and actually automate this on top of the data lake. And the last use case is the quality of medicine. It's really about improving the medication management in the hospitals. So data lake as a solution is already available since May. And a number of frontline systems are already onboarded on this data lake. As Zoran mentioned in his keynote speech, that 30% of our data is already in the cloud. And we have onboarded about, I would say, 30 to 40% of these frontline clinical systems already onto the data lake. Now, this is a long journey. There are a number of applications that we still have to onboard on this data lake. This journey will likely continue for next 12 months. We are also actively encouraging the analytics teams within health to start leveraging the data lake for their new data extract or new analytics projects. And I'm already seeing that people have started to embed data lake into their architecture. Gradually, we expect the data lake to become the feeder system for our existing data warehouses. So which means these data warehouses that are drawing the data from these production systems today can switch to actually start leveraging data lake going forward. And over the next couple of years, we expect the data lake to become a critical part of all of our future data operations. I would like to wrap up by thanking you for the opportunity to share the work we are doing at New South Wales Health. This is a great forum for sharing ideas, and I expect to learn from other leaders in the room. And I would hand back to On. Thank you.
All right. This is working. Thank you, Hamid. Those really were some great insights, and we're really excited to see what you're doing, and we look forward to seeing the outcomes of these key use cases supported by the data lake. And I would encourage you, the audience, to think about how you can leverage a modern data architecture to accelerate your organization's data strategy. I'd like to leave you with a few resources to get you started or learning more. There's links to the New South Wales Health blog that dives deeper into what New South Wales Health is doing with data, and the AWS white paper that goes into the modern data architecture. The last link here is the series of workshops that you can use to get your hands on AWS data services, learn from them, build on top, and use them to solve your business problems. We also encourage you to get engaged with our training and certification content. There's a number of free digital courses available for you to learn from, and use certifications to validate your skills. Thank you for attending this session, and we hope you find it valuable and learned something new. Looks like we have a few minutes for Q&A, so we will pass the mic around for any questions that we've got from the audience. But before you go, please take a minute to complete the survey. Provide us your feedback. We really value that feedback. We want to know what you think went well, how we can improve these sessions in the future. Thanks again. Enjoy the rest of the summit, and if you want, you can stay behind for a few questions as well. Thank you. If you've got any questions, feel free to raise your hand, and we'll try to get the mic over to you. Right.
Workout for today.
In your architecture that you showed, you've got your source SQL database, and then you've got Amazon RDS, and you've got your CDC going into that. What tool were you using to capture that data from the source database into RDS? Is it like DMS or something else?
Yeah, so there are multiple tools available that basically allow you to do change data capture from the relational database transactional logs. In our case, we are using Golden Gate.
Cool, thanks.
Yeah.
Thank you. Look, I just wanted to first say what an amazing presentation. That was really, really impressive. I guess the question that I had was, you mentioned we've got all these disparate data sources. We're trying to put them into a central platform where we can access that data. How does the work that you're doing, how does it integrate with something like the My Health record being done on a federal government level, where it's also a similar type of initiative to try and get a central source of truth for patient data? Is there any integration with that? And yeah, I just wanted to get a bit of an understanding around that.
Yeah, sure. So My Health Learning is currently a target system for a lot of our electronic medical record and PAS types of systems. So we're actually feeding into that. Currently, integrating with My Health records back into this data lake solution is not on our radar. But the thing is, we're not trying to onboard everything under the sun right from the beginning. The idea is if there is a project need and we need to onboard an additional system which is not on our radar today, it's absolutely feasible. So currently we haven't come across any use case for that, but if there is one in the future, we'll probably end up integrating with that as well.
Awesome. Thank you very much.
Hi, this is Ashok from Health Direct. I got a question on the external systems, and you built a bespoke file-based ingestion system. How did you build and what technology you used?
Yeah, so essentially, we are using two different protocols for this file-based ingestion. For any internal data sources, we are using an SMB protocol, so people can essentially map a drive onto their laptops, and they can actually drop files. So there are many scenarios where local health districts have bespoke, systems or files, data, lots of useful data sitting in files, CSV files, Excel files. They can actually drop these things using an SMB, protocol, which is typically just a drive mounted on your laptop. For external systems, we use SFTP because we want to make sure security is baked into everything we do. So we use that secure protocol, and we use the public-private key pair in order to allow people to then drop files securely into our ecosystem.
Was that SFTP in AWS, or you used AWS SFTP service? Or?
That's right.
Okay.
That's right. Yeah.
Cool. Thank you.
Getting there.
Kane's getting his steps in today.
Cheers, thanks. I should probably come to you, it'd be easier. I have a question. You said about tracking of cost and for serverless compute. How did you achieve that? Well, is it Amazon tags, or if things come up and on demand, but then they disappear after they've stopped being used, how do you charge for that? Or how do you track that?
So the charging model, are you referring to the data analytics platform or the data lake?
Wherever it's used. I can't remember
Sure.
if it was data analytics.
So let's talk about the data lake, right? So the way we charge our customer is, if it's a structured data, if you remember the architecture diagram, we are sending it all into Snowflake, where we have these virtual compute nodes, and the storage is actually shared. We actually assign these different compute nodes to the different customers, and they are linked to the cost centers. So we can actually track it customer by customer, what their consumption of the data lake is, especially for the structured data. The only part that's a little bit more tricky to measure for us is the data ingestion cost. Because let's say there are 5 customers, and they're all trying to subscribe to the same table, let's say table A. In an ideal world, we want to actually be able to split the cost amongst these 5 customers. We've actually managed to achieve this by looking at the query execution time and a variety of variables, like how many customers are subscribing to it. What's the frequency of subscription as well? So if somebody is looking at only a daily refresh of data, and somebody else comes along and say, I actually need hourly refresh of the data or half an hourly refresh, we actually factor that variable into an algorithm that we have built to actually distribute the cost fairly to the customers.
Great, thank you.
So that's your structured data. Unstructured data is all in S3, and there are APIs available that allows us to then measure and actually aggregate the cost for a specific project, and we are able to cross-charge it that way.
Yeah, awesome, thanks.
I think we're on time as well. Again, thank you for joining us. I hope you enjoyed the session. Please take time to provide feedback, and have a great day ahead. Enjoy the rest of the summit. Thanks all.